Okay, this is part 2 of our unit test review for Unit 8. If you missed the first video, please watch that one first as I give you a lot of background information. This is our second video, and we're going to continue where we left off. I think this is not one of the problems, so I'm going to talk to you about that and why we're doing this. All your teachers have told you. We usually do not tell you which problem is going to be on the test. We sometimes, go over topic lists and everything, but usually everything is fair game on the test, as it is on this test, by the way. We can ask you any question. But we did tell you that in addition to be ready for any other question, one of the questions that we spend a lot of time on, but we haven't actually tested you on, is finding the area of a regular polygon. We've done the hexagon when we did special right triangles, because you don't need trigonometry. You can use special right triangles. So that solution is both posted online somewhere. It's also in your notes. It's probably in your Notability bank of stuff. We've done the hexagon before. We did the pentagon in one of the review sheets for the last quiz. So if you looked at a solution guide on that one, which we posted, that has the solution to the pentagon. I believe we did the octagon too in class. We may have done it in class. Some of you may have done it in class. They all work the exact same way, so it's no big deal. So what I'm going to do, rather than doing one of those three, 5, 6, or 8, which will be one of the three that's on the test. So you'll either have 5, 6, or 8. So teach yourself those. You can use the exact same procedure I'm doing here. You're just going to have slightly different numbers. Okay. So I'm going to do a nonagon, a 9-sided polygon, just to show you that this works with any polygon. So the strategy is simply this: to find the area of a complicated figure like this, a polygon with 9 sides. I'm just going to create a bunch of triangles. There's 1, 2, 3, 4. Notice that they're all centered at this, the center here. 5. I'm not going to put a 6 here because that's when we're going to use 7, 8, 9. See? So if I get the area of any one of these triangles, of course we're going to use the one at the bottom. If I get the area of any one of these triangles, I'm just going to take the area of a triangle and multiply it times 9 in this case, right? That's my magic number. And that'll give me the answer to the problem. In an octagon, you're going to use 8, of course. If it's a hexagon, you'll use 6. And in a pentagon, use 5. And not that we're going to give it to you tomorrow, but if somebody asked you for 12, a dodecagon or something else, you just multiply by 12. So we're going to focus right now on one thing, finding the area of one triangle, right? I actually should use blue here. And we're going to use this blue triangle down here, okay? All right, now, the only thing we know a couple of things. We know this triangle is isosceles, and we know, therefore, that the base gets split by this altitude, right? We were told that that's an altitude. So the base gets split into 5 and 5. I'm going to be really careful with that because when we go to use this formula up here, we don't want to use 5. We want to make sure we use 10. But it's temporarily we're breaking into pieces of 5, okay? The other thing to note is that this central angle and this central angle and this central angle and this central angle and that central angle, which I'm not going to write on, whoops, and this central angle and this central angle and this central angle and this central angle equals 360 degrees. Okay, in other words, if you're facing this way, and we know that Jason Kidd said this about the New Jersey Nets, if you want to turn the team around 360 degrees, right? Let's use it like this. We would, turn it like this. That would be 90. That would be another 90. That's 180. That's actually how you want to turn a team around if you're not doing well, by the way. 270 and 360. Okay? So 360 is a full circle. So what we're going to do is to find out what one of these angles, right, like just this one here, or really what we're really curious about is this angle right there. To find one of those angles, all we're going to do is take 360 and divide it by the number of angles. If it's a 9-sided figure, there are 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Of course, you can always count them. We're going to divide it by 9. If it was an 8-sided figure, divide by 8. If it's a 6-sided figure, divide by 6. And if it's a 5-sided figure, divide by 5. Now, other teachers may have taught you differently. I've also shown this to my class. You can find the interior angle of a regular nonagon, which you know how to do from Unit 4 or 5. I think it was Unit 5. And you could divide that by 2 once you get that angle. And you'll get this angle here instead of the upper angles. And they're not the same, so don't be interchanging them. Okay? Either way works perfectly fine. I'm going to use this angle. I think it's the easiest way because 360 is always the same. Right? So you just take 360 divided by 9 in your calculator. And, of course, you get 40 degrees. Okay? I think when we did the Octagon, I think we got 22.5. So it depends on what it is. Just 360 divided by 8, 360 divided by, or maybe that was Pentagon actually. But regardless, I got 40 degrees. So 40 degrees is this angle here. But I don't want that angle, right? I want half of that angle because this altitude, as you know, in an isosceles triangle, splits it into two pieces, okay? Now, here's what I'm going to focus on. All I need is, I know the base, see, here's, we're looking at the area triangle. The area triangle is 1/2 times the base, which I know is 10, times the height. This is my only unknown. This entire formula right here works exactly the same for any polygon except for the 9, which might change to an 8, 6, or 5. And of course, the height of this triangle. See this h here. That's it. That's the height. I just got to put the h in there. So all I got to do, all of my work is finding really what this is. And in order to do that, I need to find this angle of 20 degrees. And notice I'm going to take my highlighter, which is my friend here, and I'm going to highlight a single right triangle. Because if you notice, the blue triangle is not a right triangle, so I'm not going to be using trigonometry, at least the trigonometry we're learning this year. I'm not going to use trigonometry to find sides of the blue triangle. I'm going to use the yellow triangle, and that's, of course, has one of the sides we're looking for, this height. Okay, so from this 20-degree angle, what do I got and what do I want? I have this, which is 5, and I want this, right, which is h. Well, from the 20-degree perspective, that's opposite and adjacent, right? Because this is the hypotenuse here, which I don't want, I don't need. So what am I going to do? Tangent, right? SOHCAHTOA. So tangent of 20 degrees equals opposite over adjacent. Okay, opposite over adjacent. Multiply both sides by h. Divide both sides by tangent of 20. Press 5 divided by tangent of 20 on your calculator. And you get approximately 13.74 rounded to the 100th place. Okay, so we're going to put 13.74 in here, right? 13.74. Okay, and then we just multiply. Oh, don't forget, we're going to multiply that by 9. So we'll just do it in all one fell swoop, okay? So easiest on my calculator, I'm going to put 0.5 for the 1/2 times 10. Don't distribute this 0.5 to both of these. I've seen that happen way too many times. It's 1/2, then press times 10, then press times 13.74, and then times 9. Okay, and you should get 618. 0.3, and it's going to be units squared. I do not think they gave us any units here. They didn't say meters or anything like that. So if they do, of course, you're going to put that squared. So we're going to put units squared. Okay, and that is the area of the nonagon. Your problem will work the same, except instead of 9, you'll use 8 into this formula here for 8 or 5 or 6, right? You'll put the 8, 5, or 6 here. We'll put an 8, 5, or 6 here. Okay. And you'll get a different angle. So this 20 would be 22.5 for 8-sided, I think it is. And, you know, for 6, it'll be 30. And for 5, it'll be something else. But you can figure that out. It's very easy. Just use this formula. And that's it. And then, of course, you'll get a different height. And you'll plug that height right into here. So the 1/2 of the 10, if it is a side length of 10, of course, the side length could change too. All right. Hopefully that's easy for you. And that's a guaranteed problem. One of these 3 is guaranteed. So if you practice all 3 of those, and the answers are all over the drive. Okay, these are review trig questions. I'm not going to fill this out. You should know how to fill this out, and I'm only going to fill it out as I need it, okay? In what quadrant is the sine of an angle? Now, remember, the sine of an angle is the y value, right? The y value. So in what quadrant is the y value negative? Well, here it is. You can see all these negative numbers here, right? These are all y values, okay? So y is positive above the x-axis, and y is negative below the x-axis, see? So right now I'm dealing with quadrant 3 and 4. So it says using the same quadrant, oh no, sorry, in what quadrant is the sine of an angle negative? Okay, that's 3 and 4, right? So 3 and 4. But the tangent of the same angle is positive. Really should say and. That's okay. And the tangent of the same angle is positive. So tangents are slopes of the radii, right? So, which I'm butchering here, so let me do this a little. Right? So all of these lines, right, are tangent lines. Well, they're not tangent lines. They're diameters, I should say, made up of 2 radii. So they're diameters. And all of those have a positive slope. So tangent is positive in 1 and 3, right? But they want, yeah, tangent is the same angle is positive. So they want this quadrant here, not this quadrant, because here all the tangent lines, or I should say the diameters, are all negative, okay? So all that just did for me is indicate quadrant 3, okay? And I'm going to use Roman numerals because that's how we name quadrants, okay? Using the same quadrant, so I know I'm in quadrant 3 again, okay? For problem 2, if the sine of an angle is -1/2, what is the tangent of that angle, okay? Well, what angle has a sine of -1/2? Well, we're going to look to the y-axis, and we're only dealing with quadrant 3 here. There it is. Anything along this line, right? This way or this way has a y value of -1/2. So this dot right here has a sine of -1/2, right? It's a y value of -1/2. So it says if the sine of an angle is -1/2, okay, so the angle here, and you remember the angles, of course, this is 180. I didn't label them, but you can do this. This is 210, right? 240 over here, 270, etc. So if the sine of an angle is -1/2, okay, that's when theta is 210 degrees. What is the tangent of that angle? What's the tangent of that angle? Okay, the tangent of that angle is the slope of the diameter through there, which goes from here to here, okay? And hopefully you memorized it. If not, you could divide y divided by x. It is slope, right? Delta y over delta x. And of course, you'll remember it's radical 3 over 3, which is the smaller of the slopes. The bigger one, if you were to go from here to here, that's a steeper slope. That's going to be radical 3. And of course, the 45 is 1. That's the easiest slope in the world. It's up 1 over 1. Okay, so the answer is, what is the tangent of the angle? The tangent of the angle is radical 3 over 3. Okay, so if the same quadrant 3, if the sine of the angle is -1/2, that must mean this angle, 210 degrees. By the way, what is 210 degrees? It's the angle from here to here. See, it's that separation, right? But again, you know those from the unit circle. When you fill them in like this, you just go around the whole circle, fill them in. So it's 210. Then they ask us for the tangent of 210. Bam, radical 3 over 3. Please don't show Dr. Stoller that I just slash. It really should be radical 3 over 3. He'll be very mad, so we're going to erase that. Okay, 4. A man walked 400. Oh, this is a word problem, so this is totally separate from the trig, right? From this unit circle trig. Okay. Let's try some new ones. Okay. So, and we'll do a slightly different problem here, even though we had these on a different sheet, okay? If I give you, this is from way back, if I give you a triangle like this, okay? And ignore the arrows, I just was using that tool. If I give you a right triangle here, okay? And I put a 5 here, let's say, and a 3 here, and I put theta here, okay? I might ask you some questions. I might say, what is the sine of theta equal to, right? I may ask you what the tangent of theta is equal to, okay? And I may ask you what the cosine of theta is equal to. Okay, so from this triangle, again, it's not from this unit circle here, from this, this is a separate section here, okay? From this triangle here, I want you to tell me, based on where theta's location here, what would the sine theta, tangent theta, and cosine theta ratio be? Notice I'm not expecting decimals here, right? I want fractions or radicals or integers. Pause the video, see if you can answer the question, and then turn the video back on again. Okay, so the sine of any angle, and this is an angle theta here, is the opposite leg over the hypotenuse, right? So, ka, toa. Very easy to remember, right? So sine is opposite of hypotenuse. So the opposite to this angle is 3, and the hypotenuse, right, h, is 5. So the answer is 3/5. So the sine of this angle is just the ratio of those two sides, 3/5. Now, when I go to do the tangent of the angle, I have a problem, right? I go, okay, tangent of this is easy. That's opposite over adjacent, see? But I don't know what the adjacent is. So you don't want to put an x or a y here. That's not going to work. So what do you think in a right triangle if you had a 5 hypotenuse and a 3 leg, what it would be? Well, you can do Pythagorean theorem. Please do that if you want. Pause the video, do Pythagorean theorem, and see if you can figure it out. Okay, but as you know, that's kind of a waste of time because this is our famous triplet. 3, 4, 5. No work required, although it will work fine with Pythagorean theorem. Remember our two triplets. This is 3, 4, 5. And our other big triplet that we use a lot is 5, 12, 13. So be ready for either one of those triplets. So that gives me the other side. Now I can write 3/4, right? Because tangent of theta is the opposite leg. This is the opposite leg over the adjacent leg. If you're still struggling with opposite and adjacent and hypotenuse, please go back to my video from during the snow day. All right, and finally the cosine's easy. The cosine is adjacent over hypotenuse, so that's just 4/5. Okay, I don't want decimals here. I know it's a calculator test, and it'll say it on the quiz. Don't put decimals here. These are asking you for fractions. They're much better, much neater, usually, than decimals. Okay, let's move on. So this is a nice problem where there's two triangles that share this red side, right? And again, we're going to find, I think we're going to find, well, one of the ways we're going to find the area, okay? So we're going to need this altitude that's in red and this whole base, right? That's the key here, so got to be really careful. All right, we can't use this triangle on the left because if you look at it, there's only one thing given. But the triangle on the right has lots of stuff given. Well, two stuff, I shouldn't say lots. Of course, there's a right angle in both. I don't really count that. We know the right triangles. But we need two other pieces of information in order to solve it. Okay, now this is the key thing we're looking for. We're going to call this H. I know it's dangerous because we use H, O, and A, but hopefully by now they're getting good at this. And it is the height of the triangle. I'm going to call this one X down here, and I'm going to call this one Y, right? Which is the distance between these two green dots and the other two green dots. Yeah. So I need both H and X. So let's find H. So from the 25 degrees perspective, H is the opposite side, and 400 is the hypotenuse. I certainly don't want to use X because it's unknown. Okay, so it's going to be sine of 25, that's opposite and hypotenuse. Sine of 25 is equal to the opposite leg over the hypotenuse. Okay, very simple problem. We just multiply both sides by 400. We multiply 400 times the sine of 25, and we get 169, right? So H is equal to 169.05, okay? 169.05. You may want to write it sideways. You don't have to. It's kind of difficult. Okay. Now, in the blue triangle, I didn't highlight it yet, but in what's going to become the blue triangle, right? This blue triangle, we now have a new piece of information, right? So now we do know one of the sides and one of the other sides. So you could do Pythagorean theorem to find y if you want. That works perfectly well. I'm going to actually find theta first, and then I'm going to find y using trig. It doesn't matter. Either way works. And in this case, there's really no advantage doing it either way. Both of them require that you use an answer that you figured out earlier, so you're not going to avoid any particular potential mistakes. So from theta's perspective, this is the opposite leg, and this is the hypotenuse. So I'm going to use sine. So the sine of theta is equal to the opposite leg over 300. Okay. Whenever you see this, we're going to arc sine both sides. I am going to show this work, even though it's not required on the actual test. Okay, so I'm going to show the work. We're going to arc sine. Now, it is called arc sine. We do write it as the inverse of sine, though, because that's how the calculator does it. So I'm going to arc sine this side. Okay, and then I'm going to try to take this side, which isn't going to work. Okay. So I'm going to take this 169.05 over 300, just move it aside. And I'm going to arc sine, which we write like this. It's called arc sine, but it's going to inverse sine. That's what we're technically saying. We're taking the inverse of both sides. And of course, when you arc sine sine of theta, you just get theta, right? That's like square rooting the square of 5, right? So you get 25 square root of this 5 to get back to the original. And on this side, that's a calculator work, right? So sine of -1, you know what you do. You press second sine. Anytime you're looking for the angle, anytime your answer is the angle, you're going to press second sine, second cosine, or second tangent. In this case, second sine. And the parentheses will open automatically in the calculator. Type in 169.05 divided by 300. You can close the parentheses and press enter, or just press enter, doesn't matter. We get 34.30 degrees. And that's rounded, of course, but not much. We don't want to round to the nearest degree just yet. Okay, and now I'm going to use that angle to find y. So I'm going to use, now here, I don't want to use my 169 because that was a rough, I mean, if it's wrong, the angle's wrong, it doesn't matter. But anyway, I'm still going to use my 300 here because it sounds like Sparta, first of all, And I know it's a correct number, so it's just going to help me with accuracy a little bit. So I'm going to take cosine, right? I'm going to use cosine. So I'm going to find cosine of 34.30 equals adjacent, that's what I'm looking for, over hypotenuse, okay? And I'm going to multiply both sides by 300. I'm going to take 300 on my calculator, multiply it by cosine of 34.30. Notice I'm keeping very detailed numbers here until the end of the problem. I don't want to round too early and then make my answer wrong. 247.83. Again, I'm rounding to the hundredth place. Okay, now here in the answer slot, I'm going to write 34 degrees because they said, or usually they say, to the nearest degree, right? So it's okay to put the 34 here, but in the problem I left it as 34.30 because that gives me more exact answers for all the other parts. Okay, so what do we need for the area of a triangle? We've done this many times before. So it's 1/2 the base times the height. Now we know the height, which we found earlier, right? It's right there. It's 169.05. But we don't know the base, right? We know what x is, and we know what y is, but we don't know what the whole base is. Well, that's easy. We're just going to take these two numbers. Oh, actually, I didn't find x yet. I'm sorry. So we did find y. So we have y. That's good, but we don't have x. So y will go in here with x added together, but I haven't done x yet. So let's do x down here. I'm going to do cosine of 25 equals adjacent over hypotenuse, right? From this angle's perspective, that's the adjacent, that's the opposite, that's the hypotenuse. Okay? Multiply both sides by 400, and I'm going to get x. So 400, always make the 400 first, times cosine of 25 is equal to 362.52. Okay? And I'm going to take the x and I'm going to take the y and I'm going to add them together because if you add x and y, you'll get the full base of this big triangle, right? Not the two baby triangles, but the big triangle. So I'm going to add 362.52. I'm going to add it to y, which is 247.83. And I'm going to get an answer of 610.35, I believe. I can read my calculator. Okay, so I'm going to multiply 1/2 times that, and then times 169.05 to get the final area, which is huge, 51,590.1. And of course, there's no, oh, there are meters, yeah, so we're going to put meters squared. Very important to put meters squared, right? So that's the area. Okay, meters squared because they gave us meters in the problem, so be ready for that. Okay, a 1 meter tall man. So this is taking into account the height of the man, like the other problem we did. So he looks up. Now, as soon as he said he looks up, what do I have to draw? You're correct. The laser beam eyes, right? The horizontal view. Here's the ground. The ground is down here, although not really critically important. It's important to realize he's 1 meter above the ground. So it's 1 meter above the ground. So he then looks up, but only 25 degrees to spot another balloon. Oh, so 35 degrees to spot one balloon and then 25 for the other. So again, let's see which one would be more, right? So here's my vision, okay? If I look up 25 degrees, I might only be here, but the 35 degrees would be up here. Now, what makes this problem difficult is that both balloons are the same height. So you may have been tempted to go like this and then like this and put two balloons directly below each other, but that's not how it happened, right? Okay, so we'll do the small one first. So the big one first. So 35 degrees, right? If that's 35 degrees, we hit a balloon. I'm just going to put a balloon anywhere randomly. And this height for the balloon is identical to the other balloon's height. So when I go to draw the other vision, which is a little lower, we'll make it in blue. So again, looking across first and then looking up only 25 degrees instead of 35, it's not going to be as high. But notice I can't end here because my balloons would be a different height. I can't end here because that balloon would be too high. So I have to end right around here because I want my balloons to be the same height. They're implying that in the problem. Okay? So this would be A because that's 35 degrees, and this would be B. And then what do? It's very important. I need to draw the height. Okay, and it tells me the height is 29, but it's 29 above my eye. Oh, no, I'm sorry. It's not that. It's 29 from the ground. I'm sorry. It's 29 all the way to the ground. So all the way down is, so watch. 29 goes from here all the way to the bottom there. Okay? All right. So if I have a foot, a meter down here, then this is actually only 28 meters in this picture. That's what makes this the slightly difficult problem. Okay, so it's 28 meters. All right, so I have two triangles here. Now, where's my angles, right? Well, luckily these are actually directly in the problem. So this is 25 degrees, okay? And that actually is part of my triangle, which is nice. I don't have to do any alternate interior stuff. And the bigger one, which is in the smaller triangle, is 35 degrees. Okay, so I think we'll work with that one first. Why not? Because that's what we usually do. So I'll take my highlighter, and I want to say, let me just focus on this one. I want to ignore the blue line. I want to focus on this, and the angle between those two is this. That's 35 degrees. Okay, so 35, you know the opposite, and you're very curious about the adjacent. You don't care about the hypotenuse at all, because it's saying how far apart are the two balloons. Okay, so I'm going to use what? Tangent, right? Because tangent of 25 is equal to the opposite. I'm sorry, I messed up. We're doing the bigger triangle. Apologies. Tangent of 35 degrees, so you got to stay in the yellow highlighted triangle, equals the opposite over the adjacent. So we're going to call this x down here. Okay? Multiply both sides by x, then divide both sides by 35, so I get 28 divided by tangent of 35. And I get x is approximately 39.98, which technically rounds up to, oh no, it's 39 point, I'm sorry, it is right, 39.988, so it's 39.99 for x, okay? And then to get, to get y, sorry, so x goes from here to here, and we'll use y in blue, and the blue, y is gonna go all the way across. How many times have we done this problem, right? So y goes all the way across because it's part of this blue highlighted triangle. Right? This is a blue highlighted triangle. There it is. Okay. And so that triangle base is going to be y. All right. And we're going to use the 25 degree angle. So we're going to use TOA again. So tangent of 25 equals the opposite 28 over y. Okay. Multiply both sides by y. Divide both sides by tangent 25. So it's 28 divided by tangent of 25. And that equals, I think, 60.05. And these are meters. I believe, right, meters? Let's see. Yeah, meters. So I'm going to put meters for both of these. Okay. And then the question is, how far apart are the balloons? How far apart are the balloons? So the balloons are simply the difference between y and x. So if y goes all the way across, x only goes up to here. The remainder is the difference. So I'm going to take 60 in my calculator, 0.05 minus 39.99, and I'm going to get 20.05, so that's technically 20.1 meters apart. Okay, 20.1 meters apart. Very similar to a lot of the other triangles that we're doing. Okay. So real quick, these are the Jeopardy problems, we call it. So which we kind of already did in one of the other questions, right? So I'm looking for where the cosine is equal to radical 2 over 2, okay? So if I fill in my unit circle, you're going to find out that my x value here is radical 2 over 2. Here is negative radical 2 over 2, as is down here. But over here, right, 0.707, if you remember, it's also radical 2 over 2 here. Okay, and this is 0, 30, 45, goes all the way around. This is 270, 300, 315, 330, and finally 360, right? So what two dots have an x value, because cosine is the x value, right? Have x values of radical 2 over 2 or 0.707. So it turns out to be these two, right? Right there and right here. So that is 45 degrees or 315 degrees. Now, you can go further than that, right? There are plenty of answers, but look at this restriction. I have to only give me numbers that are between 0 and 360. In other words, only the numbers that appear on the unit circle, not including 360, by the way. Okay, where is sine of theta equal to 1? Well, that's where the y value, sine is the y value. So I need to figure out where's the y value equal to 1. Well, that is the only dot on the entire page with a y value of 1, because everything down here is decimals and lower, right? That's the highest point. So that is 90 degrees and nowhere else, right? So we leave this blank. It says right in the directions to leave this blank, so don't put anything there. Okay, tangent of theta is the slope, right? So where is the slope radical 3 over 3 positive? Well, that's an easy one because we already did it. And it's really this one here, right? It's that diameter, okay? And that is our first dot, which is 30 degrees, right? That's 30-degree dot. So it's 30. And this dot is 30 past 180. This is 180. This is a 30-degree arc there, actually. And so this is the 210 mark. Okay? All right, you want to try one really quick? Let's do sine of theta equals negative radical 3 over 2. Go ahead, figure out what theta is, okay? Okay, so where is the y value, negative radical 3 over 2? So sine of theta is the y value, right? So in a unit circle, right? This is a unit circle. Let's be clear. It's not for any circle. It has to be with a radius of 1, okay? So where is the y value, negative radical 3 over 2? Well, if you remember, you can memorize this, of course. It's very easy. But if you remember, negative radical 3 over 2 is negative 0.866. So to make my life easy, I'm just going to go down to 0.866, negatives. This is negative 0.5, negative 0.6, negative 0.7, negative 0.8. Negative 0.866 is right about there. So this dot and this dot both have a y value of negative 8.66, okay, or radical 3 over 2. In your unit circle, of course, this would be labeled. You've already all done this. There, and this one would also have a y value of negative radical 3 over 2, okay? So the answer is 300. We didn't mark this one earlier, but this is 240, as you know. So it's 240 and 300. And then you got that one right. Okay, good. We did these problems already. So 5 blank 13. This would be 12, right? Pythagorean theorem. And all I was going to demonstrate here is that if it's upside down, so be careful. So if this was 6, 10, what, right? This is a Pythagorean theorem problem. What would this missing side be? So see if you can figure that out. Pause the video. Okay, well 6 blank 10 is really 6, 8, 10 because that's just double of a 3, 4, 5 triangle. Okay, now let's put theta here and let's ask you a couple questions. What is the sine of theta? What is the cosine of theta? And we'll do what is the tangent of theta. Okay, and I just picked randomly theta here. You can put theta here and you'll get different answers, of course, but we'll just try this one. Okay, pause the video, try it, and tell me what the answers are. Okay, so for sine of theta, for this angle, it's the opposite leg over the hypotenuse. Now, it's tricky here. The hypotenuse is in the bottom, although we've had this before, right, on many worksheets. There's the 90-degree angle. So the opposite is 8, and the hypotenuse is 10. But technically, that's wrong. You will actually lose a point for this. You have to reduce to be, 4/5, okay? Cosine of theta is the adjacent from this angle over the hypotenuse. So it's 6 over 10, but of course that reduces, so you need to put the reduced version on there. And tangent of theta is the opposite over the adjacent. So that's 8 over 6, which reduces to 4/3. Okay, guys, good luck. Remember, all the answers to any problems we didn't cover here from any of the review sheets are on the drive. They're labeled answer key. Take a look at them. Make sure you're practicing problems tonight. I wish you all the best.